Let's do another one. A barn is 100 meter long, 40 meter wide. A cross-section of the roof is an inverted catenary. An inverted catenary is something like this. You see, when you put the barn, the roof will be over there, and when you look from one side, what you see is the inverted catenary. And the equation for the inverted catenary is y equal to 31 minus 10 times e to the power of x over 20 plus e to the power negative x over 20. Well, this is a special type of function, is that right? Yes. Now find the area of the roof of the barn. Find the area of the roof of the barn. Have you got a picture of what that barn looks like? Let me see if I can show it to you. Actually, the barn will be something like this, and the catenary is what you see, that edge there. This is the curve which we call the catenary. So how do you find the area of the roof? This is the whole of the roof. The area of the roof is width multiplied by length. Actually, the width is what becomes the catenary. So if you can find the length of the catenary, which will be the length of that curve, multiplied with the length of the roof. That is the length of the roof, is given to be 100 meters. So the length of the catenary, that is this, multiplied by the length of the roof will give you the area of the roof. That's what we are after. Okay, let's do that now. So I have now drawn actually that's the barn. Now you can see that's the length of the roof there. This is the catenary. All right. So we will keep the center of the barn to be the origin. So that's the origin there. This is our catenary. And the length of the barn goes, the barn is actually that way. This is the length, which is 100 meter. So that's the origin. Since the width of the barn is 40 meter, the width of the barn, this is 40 meter, that means this will be negative 20 and that will be positive 20. Is that right? That's the advantage of taking the origin at the center. Now, the length of the barn is 100 meter. That is 100 meter. So what we need to do to find the area of the barn is to find the length of the catenary, and the equation of the catenary is given. So we use the arc length equation to find the length of the catenary, then multiply it with the length of the roof. That will give you the area of the roof. Alright, so the inverted catenary is like the upper part of an ellipse. Is that right? Doesn't it look like the upper part of an ellipse? If that is the upper part and that's the lower part, you actually get an ellipse. Well, and the equation of the catenary is y equal to 31 minus 10 times e to the power of x over 20 plus e to the power of negative x over 20. That's right. And once you find the length of the catenary, multiply that with the length of the roof. That will give you the area of the roof. Alright, let's start. We start by finding the length of the arc. And what is the equation for the length of the arc? Integral x equal to negative a to b, so negative 20 to 20, square root 1 plus dy by dx all squared, which means we need to find dy by dx of this and take the square of that, and then take the square root of that whole quantity. All right? Okay, that's a challenge, so let's get going. We got y equal to this is our function. What is dy by dx? Let's find the derivative of that. The derivative of 31 is 0, and this quantity multiplied by negative 10, so that negative 10 will stay as it is. And let's find the derivative of each of these. Remember, the derivative of e to the power of ax is a e to the power of ax. Is that right? Okay, let me write down and see if I can show that to you. All right. Now, you have e to the power of ax, the derivative d by dx of e to the power of ax is a e to the power of ax. Now, look at this. What is the derivative of e to the power of x over 20? Now remember, x over 20, I'm going to write it like this. E to the power of 1 over 20x. So our a, this a is 1 over 20. So the derivative of that will be, if you find the derivative of this, d by dx of e to the power 1 over 20x will be 1 over 20 e to the power of, well, 1 over 20x or x over 20. Is that right? So the derivative of e to the power of x over 20 will be 1 over 20 e to the power of x over 20. Similarly, the derivative of e to the power of negative x over 20 will be negative 1 over 20. So that negative sign will come there. Alright, so watch this. 1 over 20 e to the power of x over 20 is the derivative of that. Minus, how does the minus sign come? Because the derivative of x over negative x over 20 is negative 1 over 20. So negative 1 over 20 e to the power negative x over 20. That is the derivative of that quantity. Okay, let's get out of this and continue. So we found the derivative dy by dx. What is the next step? We want to find the square of this. And to do that, first of all, let's simplify this. The 1 over 20 is common, so that will be 10 over 20. The negative 10 over 20 times e to the power of x over 20 minus e to the power of negative x over 20. I hope that is no problem. What all we did is we factored out this 1 over 20. That gave you that negative 10 over 20. That negative is right there. And that will be negative 1/2 e to the power of x over 20 minus e to the power of negative x over 20. Well, that is dy by dx. We need to find dy by dx raised to the power of 2. So what do? Find the square of that. The square of that will be 1/4. The square of negative 1/2 is positive 1/4. E to the power of x over 20 minus e to the power of negative x over 20 all squared. Okay, what is a minus b all squared? A minus b all squared is a squared minus 2ab plus b squared. So the square of this. Now remember, in order to square a quantity like this, what all you need to do is multiply the power by 2. Is that right? So what is the square of e to the power of x over 20? The square of e to the power of x over 20 is e to the power of x over 10. The square of e to the power of 5 over 2 is e to the power of 5. So square of e to the power of x over 20 is e to the power of x over 10. And the square of this will be e to the power of negative x over 10. Alright, so let's write down that quantity. That will be 1/4 e to the power of x over 10. That's the square of this. Then minus the middle term. The middle term is 2 times a times b. So minus 2 times e to the power of x over 20 times e to the power of negative x over 20. That gives you minus 2ab plus the square of the last term. The square of the last term is e to the power of negative x over 10. So what we have is, we squared 1/2, that gives you 1/4. The square of this, a squared minus 2ab plus the square of b. That's what we have here. Now, why have I used the red color here? What is the value of e to the power of x over 10, e to the power of x over 20 times e to the power of negative x over 20? What is x to the power of 2 multiplied by x to the power of negative 2? Now remember, when the bases are the same, let me show that to you. I know some of you will have problems. Now, x over 2 times x over 3 is x to the power of 2 plus 3, which is x to the power of 5. X to the power of 2 times x to the power of negative 2 is x to the power of 2 minus 2, x to the power of 0, which is 1. So e to the power of x over 20 times e to the power of negative x over 20 is e to the power of 0, is that right? When you add these, and that will be 1. So what you see here is the middle term. This quantity in red is actually 1. So what will be the next step? That will be, I'm going to use this as 1 and then distribute the 1/4. So that will be e to the power of x over 10 divided by 4 minus, this is 2, multiply that 2 with 1/4 gives you 1/2. So that will be minus 1/2 plus e to the power of negative x over 10 divided by 4. I hope you understood that. First of all, these two multiplied will give you 1, and then distribute the 1/4. There you are. Okay, this is dy by dx all to the power of 2. What is the next step? We got to find 1 plus dy by dx, the quantity raised to the power of 2. Now, to do that, first of all, let's organize this. Can I write e to the power of x over 10 over 4 as the square of e to the power of x over 20 divided by 2? Yes. Now, remember, we said the square root of e to the power of x over 20 is, no, the square of, if you take the square of e to the power of x over 20, it will be e to the power of x over 10. And the square of 2 is 4. So e to the power of x over 10 over 4 can be written as e to the power of x over 20 divided by 2, that quantity raised to the power of 2. Did you understand that? Because if you raise the numerator to the power of 2, you get this. 2 squared is 4. Alright, minus 1/2. And how do you write this as the square of a quantity? E to the power of negative x over 10 over 4 can be written as e to the power of negative x over 20 over 2, the quantity raised to the power of 2. Alright, so this is now of a form a squared minus 1/2 plus b squared. Right, that is dy by dx, the quantity raised to the power of 2. We want 1 plus that quantity raised to the power of 2. What all we need to do is, on the right side, you add a 1. That is 1 plus all this quantity. And the only change that will come there is 1 minus 1/2 will become positive 1/2. So, as a result of adding this 1, this negative 1/2 became